Back in the late 70s, early 80s, electric cars were a pretty big deal, and that was because it was the fuel crisis. Well, Gulf Western brought out an electric car with a new kind of battery using zinc and chlorine. Actually, they produced two. One was meant for electric vehicles and the other was meant for home storage. The big deal about zinc and chlorine is it can have up to 6 times the energy density of lithium, and that got everybody excited, and actually still gets everybody excited. Now I'm going to show you Gulf Western, or rather a bit of Gulf Western's video where they explain how the battery works. I thought about redoing it, but actually it's a pretty good explanation if you can forgive the fact that it was made in the 80s and it's got a bit of pop music over it. Even so, it's a very good explanation. And from that we'll look at where those batteries are now, because of course having that kind of energy density means they're extremely interesting to people.
The principle of zinc chloride electrochemical coupling had long been known, but no one knew how to store the chlorine safely. G&W's discovery was the key to making the system viable. The breakthrough was achieved by storing the chlorine as hydrate, Cl2-8H2O. Chlorine hydrate is an ice-like material in which 8 water molecules surround each chlorine molecule and insulate it safely. It freezes at a relatively high temperature, 48 degrees Fahrenheit, and decomposes slowly. Here's how this system works. Each unit consists of 2 chambers, a store, and a cell. Is totally sealed, and all parts requiring maintenance are on the outside. Each full-sized unit contains 60 cells holding 4,002 graphite plate electrodes. Half of these plates are alternately spaced zinc electrodes, and half are alternately spaced chlorine electrodes. Importantly, because the zinc chloride system has no active materials in its electrodes, it does not consume itself and deteriorate as do the lead acid and zinc nickel oxide systems. In a fully discharged unit, the electrolyte, a solution of water and zinc chloride salt, is held in the cell and the store. To charge the unit, a pump motor circulates the concentrated electrolyte from the store to the cell chamber. There, the zinc in the solution is attracted and deposited onto the zinc electrodes. The chlorine in the solution then escapes as a gas and is pumped into the store, where, in mixture with water from the diluting electrolyte, it is chilled and forms frozen chlorine hydrate. This circulating process continues until all of the zinc is coated on the zinc graphite electrodes and all of the chlorine mixed with water is frozen in the store chamber. The remaining warm water from the electrolyte is held in the cell chamber. The entire process requires 6 to 8 hours for a 100% charge. To produce electricity, the warm water in the cell is pumped into the store, where it gradually melts the chlorine hydrate. This melted hydrate is circulated into the cell, where, as it passes through the graphite plate electrodes, the chlorine gas, which is like carbonated gas in soda water, is released from the hydrate and combines with the zinc on the zinc graphite electrodes. This coupling produces electricity at the system's terminals. Then the used coupled zinc chloride falls back into the circulating solution in the cell, reforming the zinc chloride electrolyte in ever-increasing concentrations until the chlorine hydrate has been completely melted. When this occurs, the system has delivered its full charge of electricity, and the electrolyte is once again a 100% concentrated solution.
So a pretty slick and elegant system with a fairly impressive chemistry, and as I said before, this is supposed to be 6 times what lithium has at the moment. And you might ask yourself, well, given that the US government invested something like $15 million at the time in it, which is a small fortune, what happened to it? And the first thing you might wonder is, well, was it the chlorine? Because of course chlorine is pretty hideous stuff and was used in the First World War to dramatic effect, but studies were done, and it was shown that the chlorine, in fact, even in the collisions, wasn't the real issue. The real issue was the battery only held 35% of the charge that it was supposed to have, and it was difficult to recharge. You need a technical crew to be able to do that. And of course, that really at the time sounded the death knell for that particular battery. However, as I've said, it is such a promising chemistry, as are lots of these types, like bromine and iodine, which are included in chlorine batteries because they're all halogens. These kind of batteries hold great promise, and of course chlorine as a battery has been revisited many times, and this storage of the chlorine is also being looked at. And it was in 2021 that Stanford released this news release. Now, they used sodium or lithium as the metal instead of zinc, but what they did was tackle the chlorine storage problem. They coated the cathode in a microporous carbon, an activated carbon. And what happens is the chlorine gets stuck in the tiny pores of the carbon, and this will happen with any halogen. Bromine does it, and iodine does it as well. Tackling that problem meant that the chlorine was there. It didn't have to be pumped around or separately stored, and so it speeded the whole process up and made for a very much better battery. But then, in 2023, this paper came out. What it did was it coat the cathode, the carbon, with a layer of manganese dioxide, and it turns out that manganese dioxide will assist with the actual reaction. It makes it much quicker and much more complete, and so we're upping the energy density, and they went back to zinc in that paper. So the zinc and chlorine battery really took a huge leap forward. Because if you think about the structure of the zinc chlorine battery, what it is really is what's called a flow battery. Instead of having all of the materials in one place and charging and discharging it, you keep them apart and then you pump them into the chamber where you want them to react. And that's the characteristic of all flow batteries. And that structure of a zinc chlorine flow battery has been taken up by this company, Nanoflow Cell. Now, the car's been in development for some time, but it was only 2 months ago that they announced that they were ready to rock and roll and begin production in the US. The claims are pretty grand. They say that it runs for about 2,000 kilometers or 1,200 miles between top-ups, and it has something like 600 watt-hours per kilo energy density, which is pretty cool. They also say that it runs on nothing more than salt water with a special additive they call the bi-ion. Now, the bi-ion is likely to be a little bit of BS, maybe there's a bit of chemistry behind it, but the telling thing is the salt water, which is sodium chloride. So they're clearly using some kind of flow battery that's related to the zinc chlorine battery, and it's now, like Stanford, a sodium chlorine battery. Whatever you think about the Quantino, of course time is going to tell whether it actually works or not. What it shows is that this idea of a chlorine battery, far from being a dead idea, was first developed in the late 70s to early 80s, has gone through a whole load of progressions, and now a version of it is appearing in ready-to-produce cars, which is pretty exciting stuff and holds up that idea that using chlorine for your reactant is very doable as long as you rethink some of the ways of doing it to make it safer and better, which certainly seems to be being done. And it's a question of really watch this space, because just like replacing sodium or lithium with zinc has been done, the next iteration of this, I wouldn't be surprised if they're back to zinc and chlorine with some combination to improve the reaction kinetics, that's make it faster, improve the amount that it can actually charge and discharge by, and improve the chlorine safety. Those look like they're being done, very much like they're being done, in which case we could well see the zinc chlorine battery right back there. Or maybe, given Nanoflow Cell, that's exactly what we're seeing. Anyway, I thought I would update you with what's happening with zinc and chlorine, especially when it comes to vehicles. I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.